Welcome to my channel, amazing friends, and in this tutorial I'm going to expose you to the concept of indices, or what you call the exponent. Yes, the rules guiding it and how to apply it in solving math problem. Remember, indices is an important aspect of algebra and mathematics at large. So join me as we do this together. Note, what happens when you have a number like this? You will notice that this 3 is multiplied repeatedly 4 times. Now, this can be written to be in this form. Just pick one of these because it's the same. You can just place it this way and count the number of times it is multiplied, which is 4. Then you write it at the top. Now, when you see something like this in mathematics that involves a number and another one is placed on top of it, such is what we call the indices or exponent. Remember, when it is one, it is index, and many is indices. Now, what does this indices mean, or what does index mean? Let's go back to this. Now, when you look at this, you notice that this 4 is telling you the number of times 3 is multiplied, just like we have it here. So it means that if I have a number like this, what does it mean? It means that this 2 is going to be multiplied 5 times in this form. I hope you are with me there. So this is what this means. And what does index mean? Index, remember this one is what we call the index, or what you can call the power, or you can also call it the exponent. Okay? Now, this is what we call the base. I hope you are with me there. Now, what does index mean? It simply means the power to which a number or variable is raised. I hope that has made sense now. Okay, now we can generally say that we can have this as a to the power of m, expressing index. And what does it mean? It means that this a is going to be multiplied m times. We don't know what this m means. So it means you are going to keep multiplying, and so on. So you can just express it as multiplying a m times. I hope you have understood the concept of indices. So now that you've understood it, let's now review some of the rules that are guiding it. Then for the rules, we are using this space to state the rules. Then here, we use it to illustrate. So pay attention. So we take the rules and we start with the first one. Now, look at what we have here. What does it mean? When you have something like this, let me remind you of something. When you have 3 to the power of 2, remember we said this means that 3 is multiplied 2 times. Then you multiply this again by 3 to the power of 3. This means that 3 is multiplied 3 times. I hope you are still with me there. So if you open up this bracket, you are going to multiply out. And if you do that, you see what we have. So 3 is multiplying 5 times. And what does it mean? It means that 3 will be raised to the power of 5. So what did you observe? You observe that when you have this, provided their bases are the same, it is just as you taking 1, and then what do you do to the powers to get 5? You just added. So you just do 2 plus 3. And when you do it, it's going to give you back this. Did you see that? So when you have this, what does this rule state? It states that this is equal to a to the power of m. The multiplication sign turns to addition. Then you have it this way. We call this the multiplication rule. I hope that is understood. Now let's take the second rule. The second rule is when you have, but remember, you must make sure that these bases are the same for you to apply this rule. So let's take the second one. This is what we have, and it's dividing. Now, what happens when you are dividing? We are going to have it that, let me just remind you also, if you have 3 to the power of 3, it's being divided by 3 to the power of 2. What does it mean? This means that 3 is multiplied 3 times, okay? Then divide it, you divide by this. Did you see it? So this will cancel this, and you'll be left with 1 3. So what do you do invariably? It means that this is the same as 3. Then what did you do to the power to get this? It means you are going to subtract. So it means you are going to have 3 minus 2. And when you subtract 2 from 3, it gives you 3 to the power of 1. And as we go along, we are going to see that when you raise a number to the power of 1, it is always that number. So this will still give you back 3. So when you have something like this, what do you do? It's going to be, provided the bases are the same, just take 1, and then what do you do to the power? It turns to subtraction. So you subtract. Interesting. We call this the division rule. Now let's take the third one. The third one says each time you raise a number to the power of 0, it is always a 1. So in that case, we have this. And how did we get that? Now let's look at this. If you have 3 raised to the power of 3 is divided by 3 raised to the power of 3, what do you do? If you obey this, if you obey what you have just stated, you are seeing you are going to have 3 to the power of 3, okay, minus 3, which will give you 3 to the power of 0. And what will be 3 to the power of 0? We are going to see to that. Now let's do it the other way around. We are going to have 3 is going to be 3 here. Then you divide it by 3 being 3. Did you see it? And when this will cancel out, you see you are going to be left with 1. So what it means is that this 3 to the power of 0 is the same thing as 1. So when you have a number raised to power of 0 is 1, and you have seen that example. So we can say that if you have another number, like say we have negative 2 raised to the power. Okay, let's say we have a number like 5 to the power of 0 is also 1. That is settled. Then we have the next one. If you have a over b to the power of n, what do you do to this? To simplify this, you are going to use this power on these both values. Okay, so this is going to give you a will be raised to power of this n, and b will be raised to power of n. I hope that is clear. Now let's take example on that. So what do you do? Now supposing you have a value like, let's say we have, if you have 3 over x is raised to the power of 2. What does it mean? This means that this 3 will be raised to power of 2 and this x will be raised to power of 2. Now supposing you change this x to a value, let's say we put a value like 2 there. So it's going to be 2 will also be raised to power of 2. And what is 3 raised to power 2? It means 3 will multiply 2 times, and that will give you 9. For this, it means 2 will be multiplied 2 times to give us 4. So this is what we have, which will give you 1 whole number. So we're going to have 2 whole number 1 over 4. Did you see it? So each time you have this, please express it in that form. Then the next rule is rule number 5. And rule number 5 says that each time you have a number 1 raised to a power of anything, okay, raised to a power of any number, it is always what? 1. I hope that is cleared. So when you have a number 1, example, you can also have, like when you say 1 raised to power x, it will give you 1, okay? You can also say 1 raised to power of 0 will still give you 1. So each time you raise a number to a power of any number, it gives you 1. So let's take the next one. And the next one is rule number 6. And what does that rule say? It says if you have a raised to power of, you have a raised to power, this a will be raised to the power of n and is also raised to power of m. What does this mean? It means that you are going to have it, this m will multiply n, and when it multiplies, it's going to give you nm, okay? And it means it's going to be the same as a raised to power m, then be the same as this. So this is the same as this, and this is also the same as this. So when you have it this way, you can also express it in any of these two forms. I hope that one is clear. Now let's take example on that to illustrate. So we can have it that if we have 2 to the power of 2 is raised to the power of x. We are explaining this. Now, this can be written as 2 to the power of 2. You multiply this, okay? And when you multiply it, it gives you 2x. So you can also write it as 2 to the power of x, then raised to the power of 2. So these three are the same. So whichever one you express it like, it gives you the same thing. So that one is what we call the power rule. Now let's get to the next rule, which is rule number 7. And in that rule we have it, if you have AB is raised to the power of m, what does this mean? It means that this power is going to affect the two numbers inside the bracket, still on the power rule. So we're going to have it, A will be raised to this power of m, and B will be raised to the power of m. So this is what you have. Now let's take example on that. Now our example will be, if you have 3, let's say we have 3x is raised to the power of 2. What it means is that these two will affect 3 and also affect x. So it's going to be 3 will be raised to the power of 2 and x will be raised to the power of 2. So we are going to have 3 raised to the power 2 is 3 multiplied 2 times, and that will give us 9. So we have 9x squared. So what it means is that when you have this, it means 9x squared. I hope that one is clear. Still on the power rule. Rule number 8. So what do we have here? Each time you have a number and it's raised to a power of 1, it is giving you what? The same number. Remember we said this number shows the number of times it appears, okay? So it means it's going to appear once, and that's why we have this. So we can just have example like 3 raised to the power of 1. You just have it as 3, okay? And so many of them. Now let's take the next rule. And the next rule is rule number 9. And what does the rule says? If I have A is raised to power of 1 over n, we call this the fractional exponent rule or the fractional index rule, because this power here is fraction. So what do you do to this? What you simply do is you use the denominator of this fraction, the denominator, to form the root, okay? Then put this inside. This A will be inside, okay? And this one, you raise it to the power of this. So, and you know we have said it here, when you raise a number to the power of 1, it returns you to that number. So invariably, you can just have it that when you have this, it is just the same as this. I hope that is clear. So let's use example on that. And supposing we have, let's say we have 3 is raised to a power. Okay, let's say we have 27 is raised to power 1 over 3. How do you do this? You use this to form the root, and when you form it, it becomes cube root, okay? Put 27 inside, okay? So neglect this one because you have seen that raising it to the power of 1 is still that number. So you ask yourself, what number will you multiply 3 times because of this? So what is that number you multiply 3 times to give you 27? It is what? 3. Because when you multiply 3 times, it gives you this number. We call this number inside the radicand. So this will now give us 3 as an answer for simplifying this. I hope it's clear. Now, let's look at the next rule on this. We call it rule number 10. Still on this fractional exponent rule or index, we have it A raised to power m over n. Observe that what we have at the numerator is no longer 1, is now another value. So when you have it, just obey the same rule, use this to form the root, and you put this A inside, and then at this point, you can raise it to the power of this m, because m is not 1. I hope it's cleared. So let's take example on that. Now we can have something like this, 27 raised to power 2 over 3. We are explaining this. What do you do? Just like we did it here, use this to form the root. You put 27 inside, and at this time, raise it to the power of 2. Okay, so you have it this way. And this will now give us, this in the bracket is 3. You raise to the power of 2. And this gives us 3 multiplied 3 to give us 9. I hope you've seen that. So this gives you 9. And remember, This can also be written as this. You can also write it this way, a, and then raise it to the power of m. You can put it this way or you can write it this way. These are talking about this. I hope that is clear. Now let's go to rule number 11. And in that rule we have, if you have a to the power of negative n, we call this the negative power rule or the negative exponent rule or index rule. And what does that rule say? It says that, let's take this off. It says that if I have 3 to the power of negative, let's say 2, what does it mean? It means you remove this negative sign. It becomes 1 over. I hope you get that. Then when it is removed, you will be left with a and then return this n as a power. So when you have this, this is what it becomes. So when you have 3 to the power of negative 2, it means to remove this, it becomes 1 over. Then return this 3 and raise it to the power of 2. Did you see what you do there? And you know that this will give you 1 over 3 raised to power 2, like we know, we give you 3 multiplied 2 times to give us 9. And this becomes your answer for simplifying this. So each time you have something like this, you can express it this way. Now, rule number 12. Now, what does this rule say? It says that if you have a fraction like this, and this fraction is raised to the power of a negative power, it is still on the fractional, this rule is still on the negative index we just treated on rule number 11. So when you have something like this, what do you do? Because the value inside this is a fraction, what you need to do is just to remove this power of negative, you need to reverse this. I hope you get that. So you reverse it, this will go up and this a will come down. Then it will be raised to the power of n. Remember, notice that this negative sign is no longer here. It has disappeared. By reversing it, you get this. And when you simplify this, obeying the previous rule we've introduced, this b will be raised to the power of n and a will be raised to the power of n. So this is what you have. Now let's take example on that. Now supposing we have a number like we have 3 over 2 is raised to the power of negative 2. What do you do? Just quickly reverse this to remove the negative sign. So we're going to have 2 over 3 will be raised to the power of 2. Did you observe anything? So in that case, 2 will be raised to power 2 and 3 will be raised to power of 2. So if you multiply this, it gives you 4 and this gives you 9. So this is what you get for this. I hope that one is clear. Now let's take care of rule number 13. Interesting. And rule number 13 says we are going to have, if you have a is raised to power of negative n over m, what do you do? Just, this is a combination of fraction and negative. Okay, so what you do is just to remove this, it becomes 1 over. I hope you got that. Then this denominator forms the root. Okay, this will be inside and then you raise it to the power of this numerator n. Remember, this can also be written as 1 over the nth root of a raised to power of n. So you can write it this way. Sorry, what we have here is m. Okay, this and this are the same. So let's take example on that. So supposing we have 2 to the power of, okay, let's say let's still use 27 to the power of negative 2 over 3. What do you do? Use this. Okay, first of all, remove this, it becomes 1 over. Use this to form the root. This will be inside and then raise it to the power of 2. I hope you've seen that. So this is giving you 1 over. Cube root of 27 is that number you multiply 3 times, like we said, is 3. And you raise to the power of 2. So this will give you 1 over. Simplify this, it gives you 9. I hope you've seen that. So this gives you 1 over 9. Now, having understood all these rules, let's apply them in answering these questions. Join me as you do it, okay? So in answering this now, which of these rules do we think we can apply here? Just think. you will notice that we are going to apply the fractional index rule. Here, we are going to use this now to form the root. Okay, so you put this here. This 32 will be inside. Then whatever thing you get, you raise it to the power of 2. Did you see how we are applying it now? Minus here, use this to form the root. So it becomes the fourth root. 81 will be inside. Remember here, anything raised to power of 1 is that. I hope it's clear. So you ask yourself, what number will I multiply 5 times to give me 32 because of this 5? That number is 2. So we're going to have 2 to the power of 2 minus. What number will you multiply 4 times because of this to give you 81? It is 3. So we have 3. So we have 2 to the power of 2 is 2 times 2 to give you 4. So we have 4 minus this 3 will give us 1 as an answer. Now, what about this? I know you must have gotten the answer, but let's do it together. So what do you do here? You remember this one is now fractional, negative fractional rule. So what you do is to remove this is going to be 1 over, okay? Then use this to form the root. It becomes square root. We put 2 here, but most times we don't. So let me remove it, okay? Then 4 will be inside. This one is 1. So raising it to the power of 1 becomes the number. Okay, so for simplifying this, this is what we have. Then for this division, we can turn it to be this. Then for this, use this to form the roots. Did you see? So we have 3 here. Put this 64 inside and raise it to the power of these 2. So we now have 1 over square root of 4 will give us 2 divided by cube root of 64 is that number you multiply 3 times to give you 64, and that will give you 4. You raise it to the power of 2. And this is giving you 1 over 2. Division sign we change to multiplication. Remember, this is over 1. Okay? And when it changes, you reverse. So we're going to have 1 over 4 raised to power 2 is 4 multiplied 2 times to give us 16. And this will give us 1 multiply 1 is 1. And this will give us 32. And this becomes our answer. And if this tutorial really answered a lot for you, let's know how much in the comment and help us to share for more people to learn these tips. Remember, you can subscribe for the more you can get. And I will see you in our next class. Bye-bye.